Starting. All right, so this one, so I cut all the past papers involving benzene that I see. All right, so this one I think was from 2019. So the last time benzene would have come was 2019. So you should expect it this year. All right, so let's go now. So a synthetic route from nitrobenzene to compound E is shown in figure 1. So how can we go from, does anyone remember? How would we go from nitrobenzene to phenylamine? Anybody remember?
Reduction of nitrobenzene. We add the tin and the concentration HCl.
All right, so tin and concentrated HCl. All right. How do we go from phenylamine? Oh, you see this right here, the N2 plus Cl. So the N2 plus, sorry, hold on. N2 plus, do you recognize it? N2 plus Cl minus?
Yes, sir.
Right, that's what is it called?
Diazonium something.
Right, yeah, diazonium
salt.
Right. So it is the same thing as doing this. All right, so do you remember how we go from the phenylamine to the diazonium salt?
Is it nitrous acid
Right.
plus sulfuric HCl?
5 degrees
Right.
Celsius.
5 degrees Celsius. Wonderful. Right. This compound down here, compound E, do you know what is the general name for it?
Yes, sir.
What is it?
The azo compound.
Right. So it's an azo compound. Good. All right. So if you have your diazonium salt here, what would you add to the diazonium salt to get your azo compound?
Phenol.
Phenol is correct. Right. Right. So this is typical. So it says write the reagents used for the reactions 1, 2, and 3. So we have the reagents. So for reaction 1, it is tin and HCl. Reaction 2, we have it there. And for reaction 3, it is phenol. All right. So you can just take a screenshot of the answers so we can just move along. All right. So just take a screenshot for me.
Sir, I have a question. Sir, for reaction 3, will it be the same the same temperature as reaction 2?
No, it's a different one.
Okay, sir.
Right.
So it doesn't need temperature.
Right. So the only time we use the temperature is when we are showing the formation of the salt. Okay. Oh, this reaction, by the way, it's called coupling. So I should put that there. So it is called coupling. So formation of the azo compound, that reaction is called coupling. So we have reduction. Let me use a different ink. So we have 3 reactions here. Reduction, reaction 2 here is called diazotization. And this third one here is coupling. Can I scroll down now?
Yes, sir.
All right. All right, so it has said state the class of compounds to which E belongs. So we know it's an azo compound and it is used as dyes. here we have an, all right, so this one was from 2019, right? So that was the last time anything relating to benzene had come. I think it's, is
Sir,
it
could you please the answer that you said for I
right?
Yes.
So the class of compound is, it's an azo compound. And they are used as dyes because they are brightly colored compounds. So used as dyes in the textile industry, clothing and textile industry. In terms of color, they are brightly colored. So they ask for a color, you can put orange. Right? So other compounds, they are brightly colored compounds. And then we went to, this one is also from 2019. And so this one now is the reactions of phenol. All right, so it says, the table below shows some reactions of phenol. Complete the table by inserting the appropriate observations and reagents. All right. Observations and reagents. So they for number one, they want the reagent. Look at the product. What is the product here? Anybody know the name of it?
sodium phenoxide.
Right. And what could we react phenol with to get sodium phenoxide?
Sodium hydroxide.
Right. So the reagent, sodium hydroxide. All right. For the second one, 2,4,6 tribromo right? What would we react phenol with to get this compound?
So
Bromine.
Right. Tell me two observations.
White
precipitate.
antiseptic, and it's going to decolorize
Right.
rapidly.
All right. So I can put any two of them. Preferably these two. With the, if I give two, put the precipitate and bromine be colorized. White precipitate forms bromine water is be colorized. If you realize aromatic chemistry is not hard based on how they do it. You just need to, all right. Let me scroll back up. All right. Can I scroll down? Just checking if you're finished.
No,
All right. When you're ready, let me know. I can scroll now, right?
yes, sir.
All right. Oh, here's the next one down here. All right, so do you know what compound this is? As in the general name for it?
Benzoic acid, that's it.
Let me show you something.
So
Hold
the
on,
one with allied.
Benzonoic.
close, hold on, but all right, which functional group do you see there? It's not an acid because you would have to say COOH. Also,
that-
think about the three reactions of phenol,
So the one with the allied.
right? The one with the acyl halide. So this is actually an ester, right? Because, let me show you. So this is a C, right? Then you have an O, then you have C, double bond O, right? So this right here is your ester group. See that? Right, so this is an ester. And when phenol forming an ester, we react it with an acyl chloride. Now, how are you going to figure out the acyl chloride? All you need to do, where the oxygen, so remember this oxygen is for phenol. You just break it right here, right? Put a hydrogen back on phenol and a chlorine on this carbon. So it means that your acyl halide just consists of 2 carbons. So 2 carbons, double bond O, Cl. All right. If I want to write the skeletal formula, double bond O, Cl. Right? So that is your reagent. So we draw an acyl chloride.
Sir, how do you name those? The acyl chlorides
All
or
right.
the acyl halides?
As in, when I look at this, how do I know to draw the structure of the acyl halide?
No, I mean like when you draw that in the reagent, if we're supposed to write the name for that, what would we write?
As in, you want to put the name of this compound.
Yes, sir.
All right, so ethanol, ET, because it's 2 carbons, so it's ethanol chloride.
Okay, sir.
Mhm. All right, so let's continue. So that was 2019. In 2018, here I have a next table again, reactions with.
Wait, sir. Why do they have a observation side? What is the observation we're supposed to see for there?
Oh, which one?
The acyl halide with phenol.
There's no observation for it. If you notice, it's blank, as in there's no,
Oh,
yeah,
okay, sir.
right. Just like with the one for phenol, right? Right. So here's this again, reactions of phenol. But this one now is 2018. All right, so again, so for this one, we want the product with sodium hydroxide I want the product and observation for bromine. So again, when you react bromine with phenol, what are the three observations?
Where precipitate formed.
Where it precipitate,
Antiseptic smell.
antiseptic smell,
There are two
right?
Decolorization.
Right? And what is the name of the product?
tribromo.
So for 6-tribromo.
Right? 2, 4, 6. Right? There are two for the structure. Right? So you draw the structure. And as yeah, go ahead.
This everything here is all the reagents and observation and structure that they will ever bring. They could bring anything else, like, or
No,
is this
right. So when it comes to phenol, it is always these three
okay?
reactions: bromine, water, sodium hydroxide, and which I'm leaving out, the acyl chloride.
Okay, no problem.
And we use it in the coupling reaction with the diazonium salt. But apart from that, right, it's always these three reactions. So just know your observation, reagent, and I was saying all you need to do is note to draw the product. So they are not interested in like an equation. All right, so once it's sodium hydroxide, what will be replaced on phenol?
The hydrogen.
H.
Right? So I'm going to get O, Na. Right. Can I scroll again? Let me say this one now is 2016. Right, before we look at the actual quick question, all right, so let's start at benzene, right? What is the name of the reactor? This compound here, what is the name of it?
Nitrobenzene.
Right, so that's nitrobenzene. All right. So how do we what is the name of the reaction in which we convert benzene to nitrobenzene?
Nitration.
All right. So we have nitration. When we're doing nitration, what are the reagents?
Concentrated SO4.
Concentrated H2SO4,
And
What?
nitric acid
concentrated
at 50 degrees Celsius.
Celsius. All right. Now, what is the name of this compound here?
Phenol.
Aniline.
Aniline or phenyl amine. All right. Now, how do you go from nitro? What is the name of the reaction by which you convert nitrobenzene to phenylamine?
Reduction of nitrobenzene.
Reduction. What are the reagents?
Tin and HCl.
All right. Tin and HCl. Now, how do we, so what, based on all the reactions we did, right? So there are no new reactions. What are the reactions that you did for phenylamine?
One with
diagram salt.
Right, the diazonium salt. So compound X, if it was to be the diazonium salt, what would you react phenylamine with?
nitrous acid and HCl.
Nitrous acid and HCl. All right, so now if you have the diazonium salt, when you react it with phenol, we would get, as it says, the dye here, right? So the dye should look like this. So as I said, these are not changing, right? As you can see for yourself. All you need to do is remember. Right? So the salt, right in here. We know that you should have a nitrogen to nitrogen triple bond, and then chlorine with a negative sign, and this nitrogen with a plus sign. All right. So good job. All right. So let's look at we have 1 over on this side. How would you go from, so we don't do any reaction for benzene to methyl benzene. So we don't do this reaction at tape. But if you do chemistry at the university level, you will do this one. All right, so how do you go from question, why did they put the bromine here and not here?
Because
Activator.
phenylamine is an activator.
Right, it is an activator. Right, when I was doing it, you notice also I had pointed out they don't have to put the 2,4. Notice they just put it at para. Right, so they could also just put it at ortho or both. So anyone can work. All right. Right, so now the actual question, what is the reagent now for converting methyl benzene to bromomethyl benzene?
The
Halogenation.
Halogenation, all right. So we're going to use Br2. Anything else?
and the catalyst.
Friedel catalyst.
That is correct. FeBr3. All right. So now they're asking us to state the type of reaction labeled 1 and 4. So we did that already. So we named all of the reactions. So we know that 1 is, we actually did not. What is the name of this reaction? Number 1.
Bromination.
All right, but in general, bromine is a what?
Halogen.
Right, so
Halogenation.
halogenation. And reaction 4, where's 4? Right, do you remember what 4 is called?
Diazotization, something like that.
Yeah, so diazotization. Give me a second. All right. Diazotization. And this one here, where we form the dye, what would it be called?
Coupling.
As a
Right.
compound.
No, the reaction is called coupling. Right. So we have nitration of benzene, reduction of nitrobenzene, diazotization of phenylamine to give the diazonium salt. And then we have coupling with phenol to give the other compound. All right, so reaction 1 and 4, halogenation and diazotization. And they asked for 1 and 4. Then they said list the reagents and conditions for reactions 2 and 4. So we did that. Reaction 2 is nitration. Oh, we did not put the condition for 4. What is the condition for 4? Which is the formation of the diazonium salt.
5 degrees.
Right. 5 degrees Celsius.
Sir, if I say below 10 degrees, it wouldn't be wrong because that's what I saw in the study guide.
No, that's okay as well. So it depending on where you get the source, right? So some will say below 10, right? If I put that, it works as well. Just like with nitration of benzene, I think some will put 50 to 55. Yeah? So it will vary a little, but not by a lot.
So, sir, that's all we need to write because
Which
why
one?
for A
For
under the
A,
reaction because like look at the mark.
it's 2
That
marks, you
looks
know.
so still.
It's 2 marks, you know.
2 mark for each.
Which one? For A? So A,
Yeah.
A asks for the type of
Where they say
reaction.
state the type of reaction.
Right.
Is it 2 mark for each or 2 mark
No
for
mark.
both of them?
2 marks for both of them. So 1 mark for each.
Oh.
Yes, so
Okay.
1 mark to say nitration, and the next mark to say the diazotization.
Okay, sir, my bad.
Yeah, man, no problem. Just clear off the board and wait. Can see. Right, so we know that that is nitration. And we know that reaction 2, it was nitration. So we put the condition 50, reagent, and don't leave out the concentrated. The concentrated nitric acid and concentrated sulfuric acid. Condition 5 degrees Celsius, you can put below 10 if you want. Then reagent, it was what again? Nitrous acid.
Sir,
Yes,
isn't nitration 50 degrees? It's
right.
not high.
50 minutes.
Okay.
Yeah. Down here, this one is for nitration. Down here with the 5 is the diazotization. Right, so you have nitrous acid and HCl. Give me a second. Right, let's continue. I draw the displayed formula for compound X. I think that was the other compound. Right, compound X, where's X? Oh, in this one, right, so X would be the diazonium salt that we drew. So X is the salt. Won't do the mechanisms as yet. We're just doing the reaction schemes. All right, so this one, write the structural formula for the products formed when phenol is treated with aqueous bromine. So by now, you can really see that the question does not change much. All right, just the format of how they ask it. They're pretty much asking you for the same thing each time. When phenol reacts with aqueous bromine, we get 2,4,6 tribromo phenol. All right, with sodium hydroxide, we get the phenoxide ion, sodium phenoxide. With ethanol chloride, ethanol, two carbons. So that will be for phenol. You must connect it to the carbon, double bond O. Let me put this one in red. So that's phenol, it must lose its hydrogen. The acyl halide, it will lose the chlorine. Remember, the chlorine is attached to the carbon with the oxygen. So you will take off the chlorine and put the carbon with oxygen of phenol. ETH tells you it is 2 carbons, right? And that's your compound. I just take a screenshot for me so I can move a little quicker. What is E3? E3. Which
It's the one with the acyl halide reaction on the same page.
on the same page?
Yes, sir.
So, right, the equation for the reaction is E3. Right. So they want to see the reaction. We have phenol. All they're doing is basically for this is not even like the equation, it's more the structure for the acyl chloride. Even if you know your structure, it is phenol, ethanol chloride. Okay. Again, all you're going to do, move the hydrogen and move the chlorine. So it's just like esterification.
Sir, so HCl would be the byproduct.
That is correct. So this chlorine is gone, so we move to the C. C double bond O. I'm going to mention if it is the byproduct. In this scenario, right, they ask you for an equation. They don't just put the major product, the HCl as well. And notice if you couldn't draw ethanol chloride, you wouldn't be able to do this reaction. All right, so let's go again. So let's just run through this quickly. Again, you can see that the questions are basically repeating themselves. Which year was this? Let me see. This is probably about what now? 2013. All right, so we have phenol, reagent. What is the reagent for this one?
NaOH.
NaH. What would be tell me the name of the compound here,
2,4,6 tribromophenol.
right? Oh, and the reagent here,
Acyl chloride.
Acyl chloride.
how many carbons is in the acyl chloride,
3.
right? H2, CH3.
Sir, so that'd be the prefix pro with the
Right.
ending of the acyl and then chloride for the name.
That is correct. So just like if it was 2, would be ethanol, 3, it would be propanyl chloride. So it's just the prefix that is changing. All right, so let's go to this one now. Right? This, then this. Right, I'm going to stop it at this one. All right. All right, so state the reagents and conditions to be used in each of the reactions at steps 1, 2, and 3. So reagent and condition for step 1, 2, and 3. All right, so tell me the reagent and condition for step 1.
Concentrated nitric acid, concentrated sulfuric acid, 50 degrees Celsius.
And 2,
Bromine water.
right? And
Friedel catalyst.
for 3,
TNF
right?
and HCl.
Correct. Because we did not interfere with the Br. We reduced the NO2 group to NH2. Notice also, when it was NO2, the bromine went into the meta position, right? Because as we know, NO2, that's a meta director. Right? Did I leave out any condition? Yes, for part 3, 5 degrees Celsius.
Sir, isn't the 5 degrees Celsius when you create, wait, would the 5
Oh,
degrees Celsius
yeah.
be
Sorry.
with the
Yeah.
salt?
Right. It's not
The greatest part,
right.
this is is only reaction, right?
Right. Yeah. Sorry about that. Thank you. Right. Take the reaction mechanism. Right. Not ready for the mechanism. For step 2, explain. All right. So for step 2, here they ask, explain why the bromo substituent occupies its position on the molecule. So for 1 mark, explain. Anybody want to try?
Sir,
It's a simple, yeah,
substitution.
go ahead.
Because the NO2 group is a deactivator, therefore it's going to direct the electrophile to move into the metal position.
Wonderful. All right, and then now, right, here's it. So benzene, nitrobenzene, and methyl benzene will react with chlorine in the presence of a catalyst to form aromatic substituted compounds. The three reactions take place at different rates. Arrange the reagents in order of increasing ease of reactivity with chlorine. So when it says in order of increasing ease, which one will you put first? The least reactive or the most reactive?
The least
Least.
Right. All right, so which one is the least reactive?
Nitrobenzene.
Right. So it would be nitrobenzene. And then
Methyl.
methyl benzene. No. Benzene, is methyl benzene less reactive than benzene?
No, sir.
Right. So it would be benzene, then methyl benzene. So once you put something on the ring, it is either going to be less reactive or more reactive than the benzene. And then they ask you for each reaction, draw the major monos. For each reaction, draw the major mono. All right, so now it says major mono substituted aromatic product. Do you understand what they're asking you here? Tell me what you would do. I just want to see if you interpret it correctly. It says for each reaction. So when it says for each reaction, how many reactions are you going to do?
Sir, 3.
3.
Right.
3.
And which positions are you going to occupy in each of them?
The first.
As in, so for the first one, all right, let me do the first one,
So it would be metal.
right? All right, so you can put one in the middle. It was what again? So let's use nitrobenzene. If I react it with chlorine, I should put the chlorine in which position?
Metal.
Right. So the chlorine would come there. So that's one reaction. It should be Cl, not Cl2. All right. And then the next reaction now, if I use methyl benzene, where will I put the chlorine?
So the second one,
Ortho.
the fourth one.
All right, so you can put it at the second one or the fourth one. Question. So this is methyl benzene. If I do this, would it be correct?
No, sir.
No.
Can you tell me why? So we know
Sir,
methyl,
because you're only substituting one of the
right,
hydrogen.
But it's a mono substituted.
right,
And mono means one.
that is correct. So we know it is auto para director, but it wants us to show mono substitution. So you can put it at the auto or the para, right? But not the two of them. They can choose to para or auto. And then now for benzene by itself, you can put it anywhere on the ring, right? So anywhere on the ring, and it will be correct, right? So that is what you will do. So benzene plus chlorine, put the chlorine here. When it's just the benzene ring, then you can put it wherever you want. And it's methyl benzene, you can put it at either auto or para. Right? All right, so I'm going to break here. We come back at 1. Right, I'm going to go to 3. I have to upload SBA grades after. All right, so we're going to go break, come back at 1, and we run through all of the reactions mechanism. All right. So I'm going to stop it here now. I will come back at 1.